L'Hospital's rule or theorem. If f of x and g of x are two functions, such that limit, we consider that x is tends to a, f of x is equal to 0, and limit x tends to a, we have the same limits, g of x is equal to 0. That is, if we substitute a here in the place of x, f of a become 0 as well as g of a become 0. And here both are 0, then f of x should be differentiable function, f dash of x and g dash of x is exist. And here we must check that g dash of a is not equal to 0. Then we can write it that limit x tends to a, f of x dividing by g of x is nothing but limit x tends to a, f dash of x dividing by g dash of x. So here once again, if we find that f dash of x is 0 for a and g dash of x is 0 for a, then this L'Hospital rule will be repeated. So we can write it, the extension of this one. So further we are getting 0 here, f dash of a as well as g dash of a is 0, then limit x tends to a, f of x dividing by g of x, we can write it as limit x tends to a, f double dash of x dividing by g double dash of x. So we can continue this one unless until we get the answer. So here, while doing the problem, we must observe that the given format may be in the form of infinite. Then we can apply this one. So sometime we have 0 by 0, infinity by infinity, infinity minus infinity. We may get 0 power 0, 0 into infinity. These are indeterminate form. So we cannot find out undefined format. So then only we can apply this L'Hospital rule. So here we have discussed in the lower classes limit x tends to 2 yes. So that if we apply here 4 minus 8 plus 4 dividing by 4 minus 4. So numerator and denominator we are getting 0. But we can do the modification of this one. Limit x tends to 2. Numerator can be written as x minus 2 whole square. Denominator we can write it as x plus 2 into x minus 2. Here we can cancel 1 x minus 2. And here if we apply limit, we get 0 by 4 is 0. We are getting the answer. But here we can say that if we are getting the form of 0 by 0, infinity by infinity, infinity minus infinity, 0 power 0, these are undefined format, then we must modify and we must bring it to 0 by 0 format first, then we can approach the answer fast. Evaluate limit x tends to 0, 2 times x into e power x minus log of 1 plus 2x dividing by x square. Solution. So here we consider this as k equal to, we apply the 0 here, we get 0 minus log of 1 plus 0 dividing by 0. Log 1 is 0, we are getting 0 by 0. So here this is nothing but f of x and the denominator is nothing but g of x. So here we are getting 0 by 0, it is nothing but indeterminate format. So if it is indeterminate form, so what we must do? Apply L'Hospital rule. So L'Hospital rule is nothing but applying the differentiation numerator and the denominator separately. Limit x tends to 0. So numerator x into e power x is there. We must apply the product rule. So 2x into e power x is e power x plus e power x into 2x is 2 minus log differentiation is 1 dividing by 1 plus 2x. Then we must differentiate 1 plus 2x also. 1 is 0, 2x is 2 dividing by x square is nothing but 2x. Now we apply the limit. So here if we apply the limits, this become 0 and this become, first one become 0 and this become 2 and this become minus 2 dividing by 1 plus 0 is 2 dividing by 0. So this also we are getting 0 by 0. So once again we must apply L'Hospital rule. Apply L'Hospital rule. So it is nothing but differentiating this one once again. So 2x into e power x. So 2x into e power x is e power x plus e power x into 2x differentiation is 2. Here 2 times e power x is e power x. Here 1 by 1 plus 2x is there. So it is nothing but minus 1 dividing by 1 plus 2x whole square. Then differentiation of 2x is 2. Already numerator 2 is there, we get 2. Dividing by differentiation of 2x is 2. So limit x tends to 0. So here we must remember differentiation of differentiation of 1 by x power n is minus n dividing by x power n plus 1. Otherwise we must apply the quotient rule. Now we apply the limit 0. So first time get 0, second time we get 2 times e power 0 plus this become 2 times e power 0. Here minus into minus is plus 4 dividing by 1 plus 0 whole square, and denominator we have the constant 2 equal to, so here numerator we get 2 plus 2 plus 4 dividing by 2. So 8 by 2 is nothing but 4. So answer for the question is nothing but k equal to 4. So here remember, while doing the problem we must check that denominator, once we got constant, further we cannot apply the L'Hospital rule. So evaluate limit x tends to pi by 2 log sin x dividing by pi by 2 minus x whole square. So here we consider this question is nothing but k, and we substitute pi by 2 here, log sine of pi by 2 dividing by pi by 2 minus x is nothing but pi by 2 whole square. So here log sine 90 degree, sine 90 degree is nothing but 1. So we get log 1 in the numerator, denominator 0. Log 1 is 0. We are getting 0 by 0 indeterminate form. Now apply L'Hospital rule. Apply L'Hospital rule. So it is nothing but differentiating numerator and the denominator. So here numerator is log sin x is there. So differentiation of log is nothing but 1 by sin x, and the differentiation of sin x is nothing but cos x dividing by, so here pi by 2 minus x whole square is there, x square differentiation is nothing but 2x, so instead of x we have pi by 2 minus x. Then we must differentiate pi by 2 minus x also. Pi by 2 is 0 and x is minus 1. So here we apply the limits. So here cos pi by 2 is nothing but 0 dividing by sin pi by 2 is 1 dividing by, here if we substitute pi by 2 minus pi by 2, we get numerator 0 by 1 is 0, denominator also we are getting 0, we are getting once again 0 by 0 format. It is nothing but indeterminate form. So apply L'Hospital rule again. So k equal to limit x tends to pi by 2. So here this cos x by sin x, we write it as cot x so that it will be easy to solve the problem. Cot x differentiation is minus cosecant square x dividing by, so here minus 2 is constant, pi by 2 minus x is there, pi by 2 differentiation is 0, x is minus 1. So here we can write it this as limit x tends to pi by 2. So minus into minus minus get cancelled, cosecant square x dividing by minus 2. We apply the limit pi by 2. So cosecant pi by 2 whole square dividing by minus 2. So here cos sin pi by 2 is 1. So reciprocal of 1 is 1. So we get 1 square is 1 dividing by minus 2. So answer is k equal to minus 1 dividing by 2 is the answer. Limit x tends to 0, log tan ax base is tan bx. So this is the form of log a base b. So here any base, with help of any base we can modify this one. We can write it as log a dividing by log b. Base we can write it as 10 or we can write it as e also. So here let us consider e, so that this one we can write it as k equal to limit x tends to 0. So this one with help of this property we write it as log tan ax dividing by log tan bx. So here if we apply the limit 0, this become log tan 0 is 0 dividing by log tan 0 is 0, so tan we get minus infinity by infinity. So here this is indeterminate format. So what we do, we apply the L'Hospital rule for this one. Apply L'Hospital rule. So it is nothing but applying the differentiation numerator separately for numerator as well as denominator. Log differentiation is 1 dividing by tan ax. Then differentiation of tan is secant square ax into differentiation of ax is a, dividing by log differentiation is 1 dividing by, here tan bx is there, tan bx, then differentiation of tan is secant square bx into differentiation of bx is b. So here if we apply 0 here, secant 0 is 0 dividing by tan 0 is 0, sorry, secant 0 is 1 dividing by 0 we get, denominator we get 1 dividing by 0. So both are indeterminate format. So instead of this one, we can do the alternative method. We first we square ax secant square ax and dividing by tan ax. Here if we reciprocal this one, we get tan bx in the numerator, denominator secant square bx. Limit x tends to 0, a by b, secant is 1 by cos square ax, then tan can be written as sin ax by cos ax, and tan bx can be written as sin bx dividing by cos bx, and the secant square bx is 1 dividing by cos square bx. So here if we simplify this one, so here we can cancel 1 cos square, 1 cos we can cancel here, 1 cos we can cancel, we get sin bx dividing by cos bx is reciprocal, we get sin bx into cos bx dividing by denominator sin ax into cos ax. Here if we substitute, we get 0 by 0, but before that we can write it this as, this is the form of sin a cos b, we can write it as a by b into, this is nothing but sin 2a, 2a is nothing but 2bx dividing by sin 2ax, numerator dividing by 2, denominator dividing by 2 get cancelled, we can write it this format. Now if we substitute 0, we get 0 by 0. So this simplification helps to differentiate the numerator denominator separately. We need not apply the product rule. The term is once simplified, we get the answer soon. So here apply L'Hospital rule. So k equal to limit x tends to 0, a by b is constant. Sign differentiation is cos 2 times bx into 2bx differentiation is 2b, dividing by sign differentiation is cos 2ax into differentiation of 2ax is 2a. So here we can cancel bb, aa we can cancel, and 2 cancel. If we substitute 0, we get cos 0 by cos 0 is nothing but 1. K equal to 1 is the answer. So here remember, say for the same problem, let us consider this as equation number 1. So I am writing this one here. Say R K equal to limit x tends to 0, a by b is the secant square bx in the numerator, secant square ax, secant square ax into tan bx is there, dividing by secant square bx into tan ax. So here in lower class we have studied that limit x is tends to 0, tan x dividing by x is 1. So here x dividing by x is there, we can write it this answer directly. So similarly we can do this for this term. Let us multiply and divide bx, and here we multiply and divide ax. So what happens? A by b, limit x tends to 0, secant square ax dividing by secant square bx. Here bx dividing by ax is there. This one if you apply the limits, this one tan x is tends to 0, tan bx dividing by bx dividing by limit x tends to 0, tan ax dividing by ax. So numerator is 1, denominator is 1. We have x get cancelled. Now if we apply 0, secant 0 is 1, cos 0 is 1, reciprocal also 1. So 1 dividing by 1 into b by a. So b by a get cancelled. We get k equal to 1. So we can solve the problem like this also.